Hi, today we are going to start lesson 5 in module 5. So far we've been working on numeric and algebraic expressions, and today we're going to do factors and multiples. So factors and multiples is something that I know lots of you have worked on previously in 5th grade math, but I've also seen lots of you working on it on iReady this year. So we're going to use our factors for today's lesson. So in fact, our goal after today is to be able to identify the greatest common factor of two whole numbers. So we've used factors before when we've done things like finding common denominators and simplifying our fractions. So let's talk about this word, greatest common factor. So factors is what we know we can multiply by to get to a certain number. So for example, when you guys get a fraction and you go to simplify it, you are finding a factor that goes into both numbers. Okay, so we're going to use our factor knowledge here. Greatest common factor. So that greatest is going to mean the biggest. Common means that they have the same. So we want the biggest number that they have the same and is a factor of those numbers. So this is going to be greatest common factor. A lot of times they will abbreviate greatest common factor with the letters G, C, F. So if you see it written like this in your book, that's exactly what they mean. The greatest common factor. That's just a much shorter way of writing it. All right, so let's get started with today's lesson. In your book, I need you to find page 296. So grab your math book, open it to page 296, and we are going to look at example 1. So example 1 says this: use a list of factors to find the greatest common factor, there it's abbreviated, the GCF, of 12 and 18. So there's two ways that we can go about this. I'm going to show you one way in example 1, and I'm going to show you the second way in example 2. You are welcome to use either of these ways as you work on your assignment today. It's really whichever way you find the easiest and makes the most sense to you. So here we go. Let's get started. The first way is to create a list of all the factors. So my numbers are 12 and 28. So what I'm going to do is to create a list of all the numbers that go both into 12 and 28. So when I think about the number 12, probably the easiest thing is to say, well, 1 times 12 would give me 12. Okay, now I'm going to go to the next number, 2. Does 2 go into 12? Yes, it does. It's an even number. 2 times what gives me 12? Well, that would be 2 times 6. Notice as I'm making my list, I'm going from low number to high number. What do I multiply it by? So then I think 1 worked, 2 worked. Does 3 work? Is 3 a factor of 12? Yes, 3 is a factor of 12. 3 times 4 gives me 12. And I know there are no other factors because 3 and 4 have no number in between them. Your factors have to be whole numbers. They will not be fractions. They will not be decimals. So I'm looking for what whole numbers are factors of 12. Here's the list, right? Same thing for 28. So start off with the first one. We know 1 and 28, of course. Let's see, does 2 work? 2 works. 2 is an even number. So 2 times what gives me 28? That would be 2 times 14. Let's see, does 3 work? Remember, if you're not sure, do our trick. 8 plus 2 is 10. 3 doesn't go into 10, so 3 doesn't work, but 4 does. 4 goes into 28. 4 will go into 28 7 times. So we have 4 and 7. Let's see, let's check 5 next. Well, I know 28 won't work, 5 won't work because it doesn't end with a 5 or a 0. How about 6? Does 6 work? That's my only next option, and 6 does not work. So here are my factors of 28. So when I look at all my factors, I look at which ones are the same. So they both have a 1. They both have a 2. Let's see, 12's the only one with the 3. They both don't share a 3. They both share the number 4. They both don't share any other numbers. So now let's go back and look at the question. We have a list of factors, and we need to find the greatest common factor. So the biggest number that both of them have. So if I look, the biggest number that both of them share is the number 4. So my greatest common factor of 12 and 28 is going to be 4. My GCF will be 4 on this. I first created the list. Make sure you go in order from low to high as you write your factors. Same thing for your second number, low to high, and then see which ones they have in common and find the biggest. In this case, 4 is the biggest number that they both share. So my greatest common factor is 4. All right, in your book, right below that, there is a check where you are going to practice this strategy using your list to create and see where the greatest common factor is. So if you would please pause the video and give them about 2 minutes to work. All right, let's see how you guys did. So now that you're back, you should have an answer for the greatest common factor of my numbers 9 and 20. All right, so in just a second, I'm going to ask you to share exactly what you did to come up with these answers. All right, remember, you're sharing a how did you get this instead of a what did you get? All right, turn and talk to your neighbor, and if you would again pause the video for them to discuss. All right, hopefully you and your neighbor came to an agreement on what you think the answer is and the process of how you got there. So here's what we're going to do. Check and see if you're correct. So when I think about all the factors that go into 9, the first one I can think of is 1 and 9. Let's see, 2 doesn't work, so I can't use a 2. 3 works. 3 times 3 is 9. That's the same number, so I don't need to write it twice. And I'm, excuse me, 4 doesn't work. 5 doesn't work. 6 doesn't work. 7 doesn't work. 8 doesn't work. And now I'm at 9. So 1, 3, and 9 are the only 3 factors for this number, right? For 20, I have 1 and 20, of course. This is an even number, so I know 2 works. 2 and 10 works. 3 doesn't work for this number. 4 does though. 4 times 5 would get me to 20. Again, remember your factors are what do you multiply together to get our number, okay? And I know 4 and 5 are going to be my last ones because they're right next to each other. No number comes in between, and a factor cannot be a decimal or a fraction. So now I've got to compare and find my greatest common factor. So let's look. They both share a 1. They don't share a 3 or a 2 or a 4 or 5 or any of the rest of them. The only number that is the same is the 1. So 1 becomes my greatest common factor. It is the number that they share. All right. So here is way number 1 to find common factors. Create a list and then see what is the biggest number on that list that these two numbers share as factors. The second way, and some of you might have seen this way, if you look at example 2, is to create what they call a factor tree. So they create a factor tree by doing this. My number is 52 and 78. So I'm not making a list, but I am instead breaking it apart. So 52. 2 will go into 52. Now, do I always have to start at 2? No. You may start with whatever number you realize will go in there. Okay? So 2 goes into 52 26 times. So I have broken this 52 into 2 numbers. 2 times 26 gets me to 52. Now I have to look at my factors and see if I can get any smaller. Well, 2 is what we call a prime number. So this is as small as I go. So 2 stays. That is going to be my smallest factor. I can't get any smaller than 2. But I can break 26 apart. So if I take 26, I could use my 2 again. 26, if I go 2 times 13, I get to 26. And again, 2 is as small as I can break this apart. It's a prime number, so I can stop there. 13, can I break 13 apart? Well, let's see. 2 times nothing will give me 13. 3 times nothing will give me 13. If you're thinking 13 is a prime number, you are exactly correct. So there is nothing that I can multiply together besides 1 and 13 that's going to work there. Okay, so 13 is also a prime number. So here's what I have. My factors are a 2, a second 2, and a 13 when I factored this number out. Okay, now I do the same thing for 78. 78. Well, 2 will go in there because it's an even number. So if I factor 78 out, I get 2 times 39. 2 is a prime number. The only thing that'll go into it is 1 and 2. So I can stop making it smaller there. 39, well, I know that 3 will work because 39 is a 3 and a 9. So 3 times 13 will give me 39. And if you remember, you told me over here that 13 is a prime number. 3 is also a prime number. There's nothing that I can multiply together, no whole number I can multiply together to get 3 besides 1 and 3. So we have 2 more prime numbers. So my factor list for 78 looks like this. 2 times 3 times 13. Now, I do the same thing that I did on the last factor list, I look for the greatest common factor. So the number that they both share. So this one's a little different because I need to look for all the numbers that they both share. And in this case, they both share 2s. They both share a 13. Now notice, they both don't share 2 2s, so I only circled that 1 2. So because they both share a 2 and 13, I need to figure out what 2 times 13 is to find my greatest common factor. And 2 times 13 will give me a 26. So the greatest common factor of these two numbers is 26. Both 52 and 78, 26 will go into both of those if I would divide them out. So my greatest common factor of 52 and 78 is 26. Again, I found that by factoring them, breaking the number apart into pieces until I ended up with only prime numbers. And then once I had that list of my prime numbers, then I'm able to see which numbers do they share. Well, they both shared a 2 and a 13. So remember, the factor list says 2 times 13. So that means I'm multiplying them together and I get my greatest common factor here of 26. Okay, this is your second strategy that you can use. So I'm going to give you a minute to work on example 2's check, which is located on 297. If you would pause the video and give them about 2 minutes to work, please. All right, hopefully you have an answer that you feel comfortable with, or you're in a position of, I feel really lost. Remember, look back at your example to help you, but I'm going to give you a partner to help you check. So with your book, you are going to move to find a partner and discuss how did you create a factor tree for 45 and 75, and what did you find as your greatest common factor? Take your book. You've got 5 to find the partner with the same color sleeves as you have on today. You've got 5, 4, 3, 2, 1. Turn and discuss, and please pause the video. So now that you've had time to discuss, let's talk about what you and your partner came up with. So 45 and 75 were my 2 numbers that I'm trying to find this greatest common factor of. So when I look at 45, the first fact that pops into my head is 5 times 9. I know 5 times 9 gives me 45. You can start wherever you'd like. Whatever fact you think of first is okay to start with. You may have to break down both sides of the number, and that's okay. So when I look at this, I know 5 is a prime number. Only 1 and 5 work here, so I can stop factoring. Nothing times anything else besides 1 and 5 will get me 5, because no fractions work, no decimals work. So let's see, can I break apart 9? My answer is yes, I can break apart 9. It will break into 3 times 3. Remember, when we're making factors, we're multiplying here. We're not adding. I don't want to know what plus what. I'm multiplying. Factors means what we are multiplying together to get our big number at the top. So 3 and 3 are prime numbers. So I'm again going to tell you what I have. I have 5 times 3 times 3. That is how I factored 45. Okay, that's what I've broken it into. Now, repeat the step for 75. So again, you're probably thinking 5 works here as well. So 5 does work here. So 5 times 25, think of your quarters. 5 times 25, and again, 5 is a prime number. So then I've just got to factor this 25. So 5 times 5. So I have a whole list of 5s here. If I take 5 times 5 times 5, that'll get me back to my 75. So when I factor out my number, I'm trying to see what are the smallest numbers that I can put together that will get me back up here to my whole number. So on 45, it's 5 times 3 times 3. And yes, you could have reversed that and did 3 times 3 times 5 if you want to put them in number order. Over here, I have 5 times 5 times 5. So then when I look again, they both have a 5 that they share. Just one, no. This side of the problem doesn't have any more 5s. This side has 3s, but this side doesn't have any. So the only number that they both share is a 5. So the greatest common factor of these two numbers is just a 5. It's a pretty small number because there's only a 5 that they both share. Right? There are iReady lessons out there that can help you with this, but as you're also working through your assignment, make sure you're stopping to ask questions if there's something that you need help on. And what I would like to know is, where are you with this greatest common factor? You're going to get an exit ticket in just a minute that checks to see if you can find the greatest common factor when you're given two whole numbers. Okay, remember on your exit ticket, it's okay to get it incorrect, because when you go to the table, you are going to discuss how to work through some of these problems. And I do not care which strategy you use whichever one makes sense to you. You also have the examples in your book that you can use as a guide to help you. Make sure that you are looking back if you are stuck on something. Once you've turned in your exit ticket, begin on today's assignment, please. You are headed to page 303, 1 through 6. On 1 through 6, you are only going to find the greatest common factor of 1 through 6. Then on number 12, that is also a greatest common factor question. And then when you get to the back, 15 and 16 are greatest common factors. All right. Today is also an iReady Learning Path Day. You need 2 lessons as a reminder for this week. Make sure you are working on both your assignments and your lessons. If you finish early and you are not on the missing work board, then you may go ahead to hands-on as well, or work on extra math if you still need to finish it up. Please remember that as you are working, you need to be working quietly. If you cannot work quietly, this iReady lessons will be sent up to 3 for the week. Please make sure you're following directions, even though I'm not there. See you all tomorrow.